Hello and welcome. We're starting a journey through the evolution of artificial intelligence. AI is everywhere now, changing how we work, but it's not just a buzzword. It has a long story that explains how it works today. Understanding this history will help you make better decisions. This guide demystifies AI's evolution for professionals. We'll focus on practical insights to answer. How did we get from simple problem solvers to creative AI, and what does it mean for your business? This story has highs and lows and key moments that changed everything. It all started with a simple question from Alan Turing in 1950. Can machines think? That question kicked off an evolution that has led to the tools we use today. Let's start at the beginning. In 1950, Alan Turing proposed the Turing test. It was a simple way to measure a machine's intelligence. Imagine chatting with two others, one a person, one a machine. If you can't tell which is the machine, it passes the test. This was a big idea. The goal wasn't just faster calculators. The dream was to create something that could reason and communicate like a person, helping with complex problems. The idea gained momentum. In 1956, researchers at Dartmouth College, including John McCarthy and Marvin Minsky, officially named their new field artificial intelligence. Their goal: build machines that could use language, form concepts, and solve human-like problems. Early AIs had impressive but limited successes. They could play checkers, solve simple algebra, and prove math theorems. But every rule had to be hard-coded by a human. They couldn't learn from mistakes. They only followed instructions. This was powerful for closed systems, but useless for messy, real-world situations. The early excitement hit a wall. Promises were too big. Technology couldn't keep up. Computers weren't powerful enough, and programming rules for every situation was too hard. The idea of a thinking machine seemed impossible. Government funding and corporate interest dried up in the late 1970s and 1980s. This period is known as the AI winter. It reminds us to manage expectations. During the AI winter, researchers changed strategy. Instead of aiming for a machine that could think about anything, they focused on a narrower goal: expert systems. An expert system is an AI designed to be an expert in one specific small area. It captured a human expert's knowledge in a database of if-then rules. Mycin, developed in the 1970s, was a great example. It helped doctors diagnose bacterial infections. Mian performed as well as, sometimes better than, human specialists. This showed that rule-based AI could provide real business value if its job was specific enough. Expert systems were useful but fragile. They only knew what they were told. If the system met a situation not covered by its rules, it failed. They couldn't learn or adapt. Building and updating them was expensive. They had knowledge, but no real intelligence. Key takeaways: AI doesn't need to solve every problem to be useful. Focused solutions are valuable. Systems relying on manual programming are hard to scale. The hype cycle is real. Focus on results over promises. This sets the stage for a new approach. To recap, we explored AI's early dreams, driven by Alan Turing's question and the birth of the field at Dartmouth. We saw that early AI, while groundbreaking, was limited by its hard-coded, rule-based nature. This led to the AI winter, a period of reduced interest. The industry responded with expert systems, which offered practical value in narrow fields but lacked adaptability. These early experiences taught us valuable lessons about managing expectations and the need for more flexible, learning-based approaches. In our next lesson, we'll see how AI made a comeback with machine learning. Welcome back. In our last lesson, we saw how early AI faced challenges, leading to the AI winter. Now, let's explore how AI made a comeback. This lesson will cover the paradigm shift to machine learning, key advancements like LSTMs, and the symbolic Deep Blue victory. Then, we'll dive into the fuel that ignited AI's explosion in the 2000s: big data, powerful computers, and open-source tools. This era truly brought AI into our daily lives. The 1990s brought a fundamental change in how AI was built. Instead of writing down every rule, researchers created systems that could learn patterns themselves, directly from data. This was the beginning of machine learning. It's the difference between giving someone a fish, which is a rule, and teaching them how to fish, which is learning from experience. The machine wasn't just following instructions, it was starting to learn. For AI to understand language or predict stock prices, it needed to understand sequences, where order matters. Early attempts to give AI a memory were recurrent neural networks, or RNNs, but they struggled to remember things for long. In 1997, a breakthrough came with long short-term memory, or LSTM, introduced by Sepp Hochreiter and Jürgen Schmidhuber. It was a much better architecture, letting AI remember and learn from long data sequences. This was critical for speech recognition and language translation. In 1997, AI stepped into the global spotlight. IBM's supercomputer, Deep Blue, defeated world chess champion Garry Kasparov. While Deep Blue used brute computing power to calculate millions of moves, its victory was huge. It proved a machine could out-strategize the best human mind in a complex game. Public interest and investment in AI started to return. This was a clear sign that machine learning was changing what AI could achieve. In the 2000s, machine learning was ready for the big time, but it needed fuel. Three things came together. First, an explosion of data. The internet and social media created billions of images, texts, and clicks for AI to learn from. Second, more powerful computers. The video game industry drove graphics processing units, or GPUs. GPUs were perfect for training AI models, making it faster and cheaper. Third, open source tools. Researchers and companies started sharing tools and datasets. Frameworks like TensorFlow and PyTorch made it possible for almost anyone to build with AI. These three enablers created the perfect environment for AI to grow. AIs don't understand words or images like we do. They only understand numbers. So a critical step was turning real-world data into numbers an AI could use. This is called data representation. For text, it's done through embeddings. A sentence breaks into tokens, then each token converts to a list of numbers, a vector. The important part is these numbers capture meaning. The vector for cat is numerically close to dog, but far from car. This core concept lets modern AI understand context. This was the decade AI became part of our everyday lives. E-commerce platforms like Amazon suggested products using machine learning. Social media, like Facebook, automatically tagged friends in photos using AI for face recognition. Google Search used AI to understand what you were looking for, beyond just keywords. Key takeaways. AI success needs the right data and computing power. Cloud computing made this accessible. AI is a data product. Quality data equals a better product. This era enabled personalization at scale for millions of customers. In our next lesson, we'll dive into the deep learning revolution. Hello again. In our last lesson, we saw how machine learning gained momentum, fueled by data and computing power. Now we're diving into the revolutions that brought AI to its current peak. This lesson explores the deep learning breakthrough that supercharged AI in vision and speech. We'll look at the attention mechanism and AlphaGo's victory. Then we'll cover the rise of generative AI, the transformer architecture, and its impact, transforming AI from an analyst into a creator. The year 2012 was a turning point. In a major image recognition competition, a model named AlexNet beat all rivals by a massive margin. It was the first time a deep learning model had won. For the first time, an AI could see and identify objects in photos almost as well as a human. Deep learning uses neural networks with many layers. These networks are inspired by the human brain and learn complex patterns from huge data sets. In 2014, another big improvement came: the attention mechanism by Bodenau, Cho, and Bengio. Think about how a human translates a sentence. You focus on key words to figure out the next word. The attention mechanism taught AI to do the same. It let AI pay attention to the most relevant parts of data when making a decision. This greatly improved machine translation and other language tasks. The 2016 match between Google's AlphaGo and Go champion Lee Sedol was a significant leap. The game of Go has more possible moves than atoms in the universe, and it needs human-like intuition. AlphaGo didn't just win 4-1, it made creative moves pros had never seen. It showed AI could master a complex game, learn strategies, and display a form of creativity. This fueled public interest and investment. In 2017, Google researchers published Attention is All You Need. It introduced the transformer, a new AI architecture. It got rid of old sequential processing. The key idea was self-attention, letting the model look at every word at once, weighing its importance to all other words. This provided deeper context understanding. Because it could run in parallel, it allowed training much larger models faster than ever. The transformer changed everything for language models. Models built on the transformer, like GPT, changed everything. AI was no longer just for analyzing, like classifying an image. It could now be a creator. This new category is generative AI. It creates new original content. Given a simple prompt, it can write an essay, create an image, compose music, or write code. The launch of ChatGPT on November 30th, 2022, made this widely available, accelerating the AI boom. This is AI as a creative partner. To summarize, we've journeyed through the deep learning revolution, beginning with AlexNet's vision breakthrough and the crucial attention mechanism. AlphaGo's strategic genius in Go showed AI's creative potential. The transformer architecture, with its self-attention, then revolutionized language models, paving the way for generative AI. This transformed AI from an analytical tool to a creative partner, exemplified by ChatGPT's launch. In our final lesson, we'll explore what drives AI's growth, its current limitations, and your role in its next chapter. Welcome to our final lesson. We've followed AI's evolution from a simple dream to creative machines. Now, we'll summarize the core ingredients driving AI's growth. We'll highlight its current limitations and risks, like hallucinations and bias. Finally, we'll define the crucial role professionals play in shaping AI's next chapter through responsible use and critical thinking. The goal remains: build tools that amplify human capabilities. AI's progress didn't happen in a bubble. It was driven by key factors. Big data gave AI massive libraries to learn from. Compute power, like GPUs and TPUs, provided raw processing power for complex models. Cloud computing made this power affordable and accessible. Neuroscience inspired early neural network architecture. An open-source culture, with platforms like Hugging Face and frameworks like TensorFlow, dramatically sped up research. These influences form the engine room of AI's growth. Even with all its power, today's AI has significant limitations. First, hallucinations. AI models can confidently make up facts or information. This is a major risk for research or critical tasks. Second, bias. AI learns from human-created data, which often contains biases related to race, gender, and culture. The AI can learn and even amplify these biases, creating serious ethical and legal risks. Understanding these is crucial for any professional. AI still lacks real-world common sense. It can write a poem but might not understand something obvious to a 5-year-old. This is a significant gap. Also, resource intensity. Training and running the largest AI models need huge amounts of electricity and money. This raises environmental and economic concerns. These limitations mean AI is not a magic bullet and requires careful consideration of its practical deployment and impact. For professionals, some key takeaways. It's an ecosystem. AI relies on data, hardware, and software. Consider the whole picture when evaluating projects. Think critically. Never trust AI output completely. Always check facts and be aware of bias. The future is smaller and efficient. Current research aims for powerful, smaller models that use less energy, improving privacy and reducing costs. This highlights ongoing innovation. We've followed AI's evolution from a simple dream to a creative partner. The story moved from rule-based systems to learning systems to generative systems. The goal remains: amplify what humans can do. Your role: be a responsible, informed user. Ask the right questions. What business problem are we solving? Is our data fair? How will we use this ethically? The story of AI is far from over. The next chapter will bring better reasoning, more personalization, and solutions to big problems. AI is one of the most powerful tools ever created, and its story is still being written. Professionals in every field now have an opportunity to help write what comes next. We are just getting started. Thank you for joining me on this journey through the evolution of artificial intelligence.